Okay, so the first 5.4, you should have a formula sheet, but we're looking at the formulas in the box at the beginning of the lecture. And all we're going to do is write some stuff out, follow the pattern. Now, the U's and the V's that you see in the formulas represent angles. So, for instance, this first one right here is the sine of U plus V. So, first angle, second angle, and then you just do the sine of the first, cosine of the second, cosine of the first, sine of the second. Is how it kind of works. So for 75 degrees, there is no 75 on the unit circle. So for my 75, I could do 30 plus 45. I could do 135 minus 60. There are a bunch of different options. Doesn't really matter which one you do. Sometimes one's easier than the other, but I'm just going to do this first one. So I write out cosine of 75 is the same thing as the cosine of 30 plus 45. Now with 30 plus 45, you certainly could write 45 plus 30. The order there doesn't matter. And so then the formula that I'm doing is this one right here. So I do the cosine of my first angle times cosine of the second angle. And you'll notice there's a minus between them. And then you do the sine of the first angle times the sine of the second angle. And now it's just a matter of doing the unit circle. So cosine of 30 degrees is root 3 over 2. Cosine of 45 is root 2 over 2. Minus sine of 30 is 1/2. Sine of 45 is root 2 over 2. And so now I have square root of 6 over 4 minus the square root of 2 over 4. Just multiply across the top of your fractions, multiply across the bottom. And because they have the same denominator, we can combine into square root of 6 minus the square root of 2 all over 4. Now it's kind of a weird answer, so let's go ahead and take a look on the calculator. So on the calculator, I'm going to go into mode, and notice I'm in degree mode. And then I'm going to type in the cosine of 75, and you'll see we get 0.2588. Now the instructions on this problem say find the exact value. That's why we can't just type in cosine of 75. So then I'm going to type in, I guess we don't have to do parentheses, but I'm going to do it all at one time. So I'm going to type in the square root of 6, get out of that one, and subtract the square root of 2, move out of there, and then I'll divide both of those numbers by 4. Since they're in parentheses, it divides both by 4, or you can do the top then the bottom. But anyway, notice you get the same decimal. So that worked. So the next one, again, there are different examples of numbers that you can use. You could do 45 minus 30. You can do 60 minus 45. Other examples, so just pick one. Let's just do the first one again. So I'll do the sine of 15, which will be the same as the sine of 45 minus 30. Now, up above, the order didn't matter because we were adding the two angles. But here, when you're subtracting, clearly you need to have them in the right order. 45 minus 30 is 15. Now, the pattern up above, when you do the sine formula, you do the sine of the first angle times cosine of the second. Then you subtract, and now you switch. You do cosine of the first, sine of the second. And what you'll notice now is you have root 2 over 2, root 3 over 2, root 2 over 2, and 1/2. So if you simplify off the unit circle, those are your numbers. And you end up with root 6 over 4 again, and root 2 over 4. And so your final answer is exactly the same. And the idea is cofunctions. When you take sine of 15, like we just did, and up above we did cosine of 75, when you do the sine and the cosine of complementary angles, 75 and 15 both add up to 90, So if you do the sine of one of the complementary angles and cosine of the other, you'll always get the same answer. All right. So then the only thing down here when you do the cosine of 7 pi over 12 is that it's in radians, and it probably is easier for most people to work in degrees. So let's take our 7 pi over 12, multiply it by 180 degrees over pi. And remember, the pi goes away. And if you do 7 times 180 divided by 12, I do 180 divided by 12 is 15 times 7 is 105. But no matter how you do it, you get 105 degrees. So the cosine of 105. I would just do cosine of 60 plus 45. So that turns out to be cosine of 60 cosine 45 minus sine of 60 sine of 45. And you'll notice you get a lot of similar answers all the time. So cosine of 60 is 1/2. Cosine of 45 is root 2 over 2. Sine of 60 is root 3 over 2. And sine of 45 is root 2 over 2. And when you do this, remember you're going to get square root of 2 minus the square root of 6 all over 4. You can go ahead and check the decimal to make sure it works. The tangents, so those tangent formulas are a little more difficult, and so I'm going to do a specific trick on this one. I would actually choose a different angle to make my life easier, but 195, there are a bunch of different examples, but for instance, let's say you chose 150 plus 45. So the tangent of 195 can be written as the tangent of 150 plus 45. In which case, you do the tangent of 150 plus the tangent of 45 over 1 minus, and now you multiply or do the product of those two angles. Now, hopefully all along you've been trying to memorize your tangent, and so I'll just do a reminder over here. Tangent of 30 is root 3 over 3. Tangent of 45 is 1. And tangent of 60 degrees is just root 3. This is root. That's root 3 over 3 right there. And so normally if I was doing a tangent formula, I would pick a 60-degree angle instead, but I want to show you a specific trick. So when you do this now, you have the tangent of 150 degrees is negative root 3 over 3, because it's the 30-degree angle in quadrant 2. Tangent of 45 is 1, and then you have 1 minus root 3 over 3, and that's negative, and this is 1. So now I have negative root 3 over 3 plus 1 all over 1 plus root 3 over 3. So the trick here is to multiply by 3 over 3, a sneaky form of 1, and that can go to those two numbers, and this 3 goes to these two numbers. And so what you're looking at is a negative root 3 plus 3 all over 3 plus root 3. And this will be a little easier for us to rationalize. Okay, so then when you have this one, we have to rationalize, and you basically kind of the conjugate of the bottom. Remember how that is? You do switch the sign between the terms, but you need a sneaky form of 1. So now we have to be careful. We're going to multiply everything on top. So FOIL. So I might start with this times both of these. And so I have negative 3 root 3. And then when I do negative root 3 times negative root 3, I get positive 3. And then I'll take this 3 times these two things, and I get 9 minus 3 root 3. And then because it's the idea of conjugates, you only have to do first and last. So that'll be 9 minus 3. So now you have 12 minus 6 root 3 all over 6, which would reduce to 2 minus root 3. And again, you can go back and type in tangent of 195 and 2 minus root 3 and make sure you have the same decimal. All right, on this problem, we're going to draw two different triangles, and so I'll do some circling here. We'll do this alpha, if you will, in red. And it tells me to draw it in quadrant 3. So I'm going to draw a triangle in quadrant 3, call it alpha. It's the adjacent over the hypotenuse. The missing side is 3, but remember that's a down direction, so you have to put negative on it. So a 3, 4, 5 triangle. We'll do beta in blue. And again, they're coming out and telling me put it in quadrant 2. Pi over 2 to pi is over here in quadrant 2. So call that beta. And beta is this 5 over 13. So opposite over hypotenuse. If you do the Pythagorean theorem, you're going to get a 12, but that's negative. So then what we're doing right here is the sine formula. So you're going to do sine of alpha cosine of beta minus cosine of alpha sine of beta. And so the sine of alpha, use the red triangle and you get negative 3 over 5. The cosine of beta, we're going to use the blue triangle, and that's the adjacent negative 12 over hypotenuse 13. And again, alpha here, cosine of alpha, we're going to use the red triangle, that's 4 over 5. And the sine of beta, use the blue triangle, that's 5 over 13. 5 over 13. And so this turns out to be 36 over 65 minus 20 over 65 for a grand total of 16 over 65. Okay, so you're going to do the next one as a DIY and come back and check the answer. So pause the video now. Okay, so you're supposed to do the, this is ultimately what you're doing, the sine of u plus v. And then I would do like u in red. So that's quadrant 1, that's this stuff right here. And then this stuff, the V triangle, this is quadrant 2, so that's this one right here. And when you do your formula, right there, you go sine of u, cosine of v, cosine of u, sine of v. And those are your numbers, and you should get negative 33 over 65.